understand how to calculate these studentized residuals by hand. But of course, there's also an R function that will do this for you called RStudent. And so again, you'll just plug in the model, the linear model object, into this RStudent function, and you'll get those studentized residuals. All right, so the last type of point we're going to talk about, we've talked about leverage points and outliers, and now let's talk about influential points. And so a common measure of an influential point is Cook's D, or Cook's distance. And this statistic, basically in the numerator, you have y hat minus yi hat transpose times y hat minus yi hat, where this yi is that fitted value leaving out the ith observation, divided by p plus 1 times sigma hat squared. And so this y hat minus yi hat, that's the change in fit after leaving out observation I. And it turns out you can actually calculate this quantity by using 1 over p plus 1 times ri squared. And so this ri is the standardized residual times hi, the leverage, divided by 1 minus hi, the leverage. So we're kind of combining a whole bunch of different pieces that we've done here. We're combining the standardized residual with the leverage point to be able to calculate this quantity that gives us some information about whether observation is an influential point. And so as a rule of thumb, you can give observations with Cook's distance greater than 4 over n an extra look. So here's a plot of that, and what I've done is on the x-axis I've plotted the index, by which I mean just the row number of x. And this data is actually that same MT-CARS data that I was plotting before. And then on the y-axis, I'm plotting Cook's distance. And so I'm plotting just the value that I got from that equation that I showed on the previous slide. And then I've drawn this dashed line here, and the dashed line falls at 4 divided by n, which in this case is 32. So I've got this line here drawn at 4 divided by 32, and I basically see that by this it looks like maybe there are 3 points that seem somewhat influential that maybe I'd want to take an extra look at. All right, so for a final application exercise, what I want you to do is calculate Cook's distance for the data above, and then I want you to plot it with the row number on the x-axis and Cook's distance on the y-axis. So on the x-axis, you're just going to have 1, 2, 3, 4, 5 for each of these x's. And then on the y-axis, I want you to plot Cook's distance.